Hello, this is Mr. Taylor, and I'm very pleased to be able to bring you the 2023-2024 Honors Chemistry naming videos. This will be a series of 5 videos in which this is the first, where we are going to be going over how to go through chemical naming. What do I mean by that? First off, if you are given a formula, like some of these right here that we will go over soon, can you tell me the name of these chemicals by looking at them? And vice versa, if I give you the name, and we'll go over some of these as well, can you tell me the formula? What this is really going to help you with is second semester when we're going through more word problems, you're going to be able to tell a lot of information by just reading the problem. So this is very, very fundamental, and it's a very, very important skill. So I'm very pleased to be able to bring this to you. So what are these videos going to look like? First and foremost, there will again be 5 videos. 4 right now that you will be getting released either all at the same time or one at a time. And this one right here on specifically naming acids will be released second semester. So don't worry about this box at all. But long story short, there is a process that you're looking at right now, a flowchart, on how to name chemicals. So what these videos will do are break down piece by piece these different parts. But I really quickly want to spend a few seconds to go over essentially what's the key concept. Is there a metal? Which means, is your chemical going to be ionic or covalent? And again, please bear with me with the typing. I apologize. I'm probably going to spell a few things wrong, go back. So I do apologize with that. But essentially, which side of this are you going to be on? So for example, is there a metal? Yes, it's ionic. Or no, it's covalent. Which brings me to the topic of the first video, which is going to be covalent. So essentially, if you have a covalent compound, in your compound and or molecule and there's nothing else there, so there's no metal, essentially, we're going to go down here for first semester. This, again, second semester is not something you need to worry about. So this video is going to go over these rules. So really quickly before we go into these, how do you know if you have a metal or non-metal? Well, if you haven't seen this chart before, this is really quickly how it works. All of these in blue are metals underneath the semi-metal staircase in the middle of the what is called P block of the periodic table, and the non-metals are going to be yellow. If you think about it, this makes a lot of sense. You know that zinc, silver, gold, iron, platinum, titanium, potassium, calcium, these are metals. Where things like carbon, which is pencil lead or charcoal, phosphorus, which is at the end of matchsticks, and a bunch of these gases I'm going over here, those are metals. So another really, really good way to look at this. I know, for example, my students have seen this. If you haven't, that's okay as well. So again, what are we going to do? First and foremost, we need to see, is this a diatomic element or molecule? What does this mean? Essentially, these 7 elements are twins. So you will never have Br by itself. It'll always be paired up with itself, essentially, if it's alone in nature. So yes, for example, Cl, NaCl is salt, but it's not chlorine by itself, it's with sodium. So these by themselves will always pair up with an identical atom. Essentially, H2, N2, and O2, which you guys have seen a bunch in biology and this year, and F2, Cl2, I2, and Br2 are the halogen ones from this year. Essentially, if you recognize these elements, you're done. With these, if it's not 2 of the same element, what you're going to do is you're going to name the first element first using prefixes, except for mono. We will go over the prefixes next. And these prefixes tell you how much of the element there is. Then we'll name the second element using mono. I will explain that as well, and I'll explain why this ending needs to change to "-ide". But first, the prefixes. So the prefixes are all right here, okay? And you will have access to these. It's not that bad. But again, mono is 1, di is 2, tri is 3, 5 is penta, 4 is hexa. So a lot of these are very similar to what they are in geometry. And we'll talk about the Roman numeral aspect later. But 4 I do want to draw special attention to because 4 is new. Geometry does not use quad. Geometry does use quad. We use tetra. So if you see tetra, that's going to mean 4. And that's a big, big important thing. This you will have access to. With the names. Really quickly, wanted to just show you an example of that, and I'm sorry if you're hearing that beeping behind the screens. You'll notice that all these have nitrogen in them. And if I reveal the names, you'll see how closely they are named. Nitrogen, nitride, nitrite, nitrate. So something to keep in mind if it helps you. Nitrogen, when it's, again, paired up, because it's one of those diatomics I just went over. Again, diatomic elements, again, are the twins of the periodic table. If you have it as a cation or anion, the ending is going to change to "ide." These are two different things. This is nitrogen by itself. This is a nitrogen that's going to be, as an ion, connected with something else. And these two, with the oxygens connected, NO2 and NO3, these are polyatomic ions, and you can tell that they are named after different things. Polyatomic ions, at least for my students really quickly, are on the back of your periodic table. You'll have a whole list of these. I'm not expecting you to memorize them, just to know if you see bigger things, flip over the periodic table, and you can see those are the two that we're going over right now. So again, just watch these, and you can see a lot of these end in ate and ite. There is an ide, but you can see a lot of ate, a lot of ite. So if you see ite or ate, you're probably going to flip it over on the periodic table. There's way more of these, but this is a great start. So with that kind of baseline information, let's get into naming really quickly. So the rule that they said that's very important that people mess, the first element using prefixes except mono. Why can't we use mono here? But we can here. Well, let's look at this math problem. You see, if you're going through a problem, if you're speaking and you see x plus 3 equals 10, you're going to say x plus 3 equals 10. That is something you would say. You would not say 1x plus 3 equals 10, because that 1, well, that's redundant. For that reason, in chemistry, we don't say one of something. We just say what it is. So, for example, starting with this one, which you can see is 1 Br. Br is bromine. So, we'll call this bromine. There's 3 oxygens. The prefix for 3 is tri. And again, I apologize, are going to have it end with an ide. So this is bromine trioxide. Going on to this one. Nitrogen has a 2 by it, so this is going to be 2. Di is 2. 2 nitrogens and 3 oxygens, so this is going to be dinitrogen trioxide. Notice the IDE ending again. This one, again, that's sulfur. We don't put the 1, so it's just sulfur. 6 is hexa, and then fluoride. Again, ending with IDE. This one, it's just 1B and 1N. Again, we're not going to start with 1, but we can put the 1 after the second one, so this would be mononitride. Again, as you can see, ide, 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 ide. And to be honest with you, if we go over here, this one will be 4 phosphoruses, which is tetraphosphorus, and then deca oxide. Again, ide. And this last one is actually very, very similar. Oxygen. Again, we don't start with mono. We do not start with mono, and that's difluoride. Again, getting those prefixes from here. If you want to take a quick picture of it, I'll pause for a moment. Awesome. And those are here. When you're going the other way around, this one a lot of people think is easier because you just have to follow what it says. So for example, chlorine monoxide. So what happens with this one is, and please forgive my handwriting with this, there's nothing there, so it's just 1 chlorine, and mono means 1, Oxide is oxygen, so it's just ClO. If you wanted to write Cl1O1, I have no problem with that. So, Mr. Nenya students who are watching this, check in with Mr. Nenya, see if he's okay with that, but I am. This one, boron phosphide. Again, B, there's nothing here, so this one's actually a mistake. Mono phosphide. This one, nitrogen trifluoride. Well, nitrogen, there's nothing here, so it's a 1. Tri means 3, F, 3. This one, tetra arsenic. Arsenic is a S. Tetra is 4. Deca oxide. Well, deca is 10. O, 10. And that's really kind of how you do these. So a lot of these, you just have to follow it. Going over here, di means 2, and nitrogen is N. So this will be 2 nitrogens. Mono is 1, so I just need 1 O. And that is how you do everything with covalent naming. Some of the videos will be a little shorter this because we went over a few things first. With the next videos, we'll kind of just jump into it. But that's all you need to know about covalent naming.